Hello again. I have an exciting new project. This project is going to take some time to complete, so I split it into parts. The first part will be shown here. It's about building a prototype and testing my new wheels. In this project, I am going to build a PMD. It stands for Pet Mobility Device. So let me introduce the stars of this project. The cutest Smoky Boy, the chubby Shirley girl, and the pretty Mama Symphony. These cats are not physically handicapped in any way, but I thought it would be so cool if I can take them walking with me without having to carry all three of them in a bag or a carrier type kind of thing. Of course, they make pet strollers like they do baby strollers, but I think that this will be so much more fun. This picture shows the undercarriage of the prototype. The drive plan on this PMD is independently controlled rear wheels. Here you can see the assembly of the two motors, and a wheel is attached to each of them. The prototype is built around the size of these two motors, and everything is scaled to them. So okay, to do this, it means you need to get the motor first, then build the box around it. The wheels are cut with 3-inch hole saw out of a 2x4. The motor plates are cut from 1/8-inch stainless steel plates, which I happen to have lying around. It so happened that my prototype can sit on its square butt. In this position, the wheels are not touching down on the surface. So this allows me to run a spinning test that is free of loading. You will see this in the video clip that is coming up next. At this point, my intention is to test the speed and direction of the wheels as controlled by a button. I programmed the code to spin for 1 second for each button push. The yellow button will forward the left wheel and reverse the right wheel. Also, when I push and hold the button, it will pause and start the cycle again. The blue button is the reverse of the yellow button. So what does that mean? We will find out in the next video. And that was just what I wanted, to spin the prototype around in a tight radius, to make the point that the wheels are independently driven. Now I flip over the prototype and we can look at the top. The Arduino unit cannot directly drive the motor because it cannot supply the higher voltage and current required by this motor. That is the reason for the L298N, a very generic, common, cheap motor controller for up to 30 volt, 2 amps, and 25 watt. Okay, this is a piece of advice. When you look at specifications like this, you need to do the math, which will tell you that the L298N cannot drive at 30 volt at 2 amps because it will be 60 watts, and that will destroy the unit. So if you are going to pull parts together for an experiment and build robotic toys, you need a bit of electrical engineering common sense, or be ready to have some things burned out. Hopefully, you have working circuit breakers in your house and will not lose your house to a fire caused by wayward electrons. In this prototype, the 12 volt supply powers the motor controller L298N. The Arduino microcontroller outputs a set of 2-direction signal and a pulse width modulated signal to the motor controller for the left wheel operation and another set for the right wheel operation. The motor controller will interpret the PWM signal to set the actual voltage that is applied to the wheel and set the motion polarity based on direction. As mentioned earlier, the left and right wheels are independently controlled. For assembly of the push buttons and screen, you can refer to my very first YouTube video. On this page is a small segment of the code showing my use of variables and technique for spinning wheel test. This code is not complete, but it is sufficient to show the gist of what I am trying to accomplish here. This is a short video of my current project, and it is all I have for now. My next step is to make it work with remote controls. So previously I used RF controls, but this time I'm going to go with Wi-Fi. More detail in my next video. Till then, ta-da!